Welcome to this session called AsyncAPI Recipes for EDA Gourmet. My goal today is to give you a panorama of many different use cases where event-driven can bring benefits in your complex enterprise information system. In this session, I'll first give you my opinion on what EDA stands for and what could be an adoption map using AsyncAPI specification. We'll again go through different recipes that highlight the features of AsyncAPI that can be used in different use cases. And also during the talk, I'll try to illustrate those features in a pragmatic way using a tool called Microcks. So first, a little bit more about me. My name is Laurent, and I'm working at Google on Daytime, where I support fintech startups, scale-ups in making their application design cloud native. I'm also involved in open source on spare time, being a member of the AsyncAPI TSC and the leader of Microcks. More on that in a few minutes. Before joining editors or cloud providers, I was working as an enterprise architect in financial services, so I think I have a very pragmatic background, very pragmatic experience on many topics related to distributed computing, enterprise integration, and API programs. And as mentioned in my talk last year, I like gardening as a hobby, but I also like food, as most French people do, and this topic of recipes. So maybe you're hungry, but before jumping to the recipes, just go back to the fundamentals for a few minutes. What's EDA? And it's pretty simple. It's event-driven for the win. And event-driven, it's a paradigm and bring new concepts, bring common concepts that are all about decoupling in time, decoupling the technology, but also decoupling the space, the location. And it brings new concepts like publisher, sender, or producers, like subscriber, receivers or consumers of events, and of course the main one, the stimulus or the event that are triggering messages. But throughout my experience this last year, I also come to a somewhat provocative question when discussing with customer or colleagues. What does the A of EDA stands for? Of course, everybody knows it's for architecture, but what does architecture mean to you? Is it technical architecture? Is it related to the logic of interaction? Is it the architecture of your information system or the organic design of your application? And wouldn't the A mean application sometimes if you focus on interacting with the user? So it leads to the question, what's an application if you're looking for a user perspective or lifecycle perspective? But in short, those questions make me think that there are different levels where EDA can make sense. Yet, EDA is not a new concept. I remember first meeting it nearly 20 years ago when we were talking about SOA, service-oriented architecture. But at that time, EDA was quite different and was mostly seen as a carrier pigeon. It was not that considered reliable. Remember, it was just the beginning of real-time system and the era of two-phase commit. And at the end of the day, people tend to prefer pure web services or batch exchanges that were way easier to operate at that time. So EDA was just standardized on a few use cases, mostly one usage, exchanging flows with partners or legacy system, and mostly in financial services. And also, even if very similar, all pigeons or EDA solutions were very different because of the lack of standards for describing their usage. But luckily, as you may know with this conference, and as you may now all be aware of, AsyncAPI saved the day, really. It saved EDA. Because this spec has this fantastic power of allowing us to precisely describe every situation. What we used to have in traditional EDA at the information system level, represented here by this API that is triggering an event that can be consumed by an email service on a CRM service. It also allows us to manage what we see in new industry, IoT, edge computing use cases at the application level, having distributed applications with a central hub and distributed devices, for example. It allows you to address what we have in modern application interaction, like streaming applications, having an API that stream event to a browser or a mobile phone. And yes, it also helps specify complex or long-running workflows like loan application, like mortgage application, and so on. So you see that it can apply to a whole range of use cases at very different levels. And all these examples and others makes me think about some kind of adoption map for EDA. A map that would encompass the application level or tactical use case, as well as the architecture level or strategic adoption drivers. And it would go from local consideration that may be driven by user interaction or deployment, because after all, as soon as you're doing serverless stuff, you're doing events, even if you don't really see them, if you don't really specify them. And this can lead you to more regional ones, trying to optimize resource consumptions or access to technologies. And then to more governed one where you can find the most large-scale application modernization initiatives or techniques like transformation of monoliths to microservices, for example. And finally, to global ones when you really see the events as the building blocks for supporting your IT transformation or enabling more agility into the business. Each category comes with its own victories or badges if you manage it as a progression, but don't get me wrong, I don't necessarily see this as an adoption path, it's a map. And in my experience, I've seen people that were really well addressing the part on the right, but totally neglecting the one on the left. So my opinion is that there are benefits to addressing all of these. And of course, with great powers come great responsibility or challenges. And it's not that different with EDA. And we see mainly two difficulties on the field. One comes from the multiplicity of protocols and formats that are supporting EDA. I would not say we're still in the carrier pigeon era, but we now address a wide variety of use cases, and we know that one size doesn't fit all. So we end up with a lot to handle. And the other ones come from the consequent complexity of environments for developing, testing, viewing, QA, and so on. And because we have decoupled things, we now have a ton of runtimes to manage. So the latest element I want to introduce before talking about recipes is this Microcks project I'm working on. This is of greatest importance as I truly think that even the greatest spec needs pragmatic tooling to unleash its value to every actor on the lifecycle. And in a few words, Microcks is a tool that help simulation and testing of all kinds of API, including the event-driven ones, through the support of AsyncAPI, of course. How we are doing that, and we are doing that by leveraging the power of contracts and example. Contracts because we are using AsyncAPI and it provides all the syntactic rules in it. And examples because examples provide illustrative real-world scenario for free, and they can be embedded into the spec as well. Most of the time in development, we neglect, or in design phases, we neglect the importance of examples. We let tools generate examples for us. And we have basic examples having random values, having always the same values, but we do think that it's a best practice to pay great attention to examples because when they are carefully chosen, they can represent real life and business expectations in a very clear way. So in Microcks, we reuse these examples to first provide you with simulations or mocks, and we are able to turn them into actionable assets so that we reuse them to realize conformance testing or contract testings. So that's a few words on Microcks, and you'll see it in actions in a few minutes. So now that we have our three elements, EDA, AsyncAPI, and Microcks, we can deep dive into recipes. And I specifically choose 6 recipes that I think are the most common ones, and that every architect, every practitioner should be aware of. Sorry. As I try to make them a bit generic to encompass the most situation possible, you'd probably need to put some context in here, but I hope they will really represent actionable patterns that you may apply later on. So my first recipe is the examples you always see when dealing with AsyncAPI. It's dedicated to user interaction and how EDA and AsyncAPI can help enhance the user or the customer experience, or at least the experience of the developer that is developing enhanced user or customer experience. So this is mainly a recipe to set up the structure that will be the same for each one. So we'll talk about the what that are the EDA patterns we'll use and the motivations. We'll go through the AsyncAPI ingredients on the right, the ingredients that can be used to implement them. And finally, we'll have a word on how Microcks can help in those situations. So in this recipe, you're looking to make a better user experience, pushing events in real time to the user through the browser or a mobile device. And this one involves the definition of a subscribe operation using AsyncAPI. Subscribe operation means that the users of the API will need to subscribe a channel to get the events, to get the notifications, to get the messages. But you can also specify user-led interactions using EDA and AsyncAPI. Imagine you want to implement a chat room or something like that, and this time you have to define publish operation on a channel so that users can send messages. And because AsyncAPI had this notion of protocol bindings, you'll be able to precisely describe the one you choose. It can be a simple HTTP for server-side events, for notifications, or it could be AWS a simple notification system for mobile, or even WebSockets in the case of a chat. So AsyncAPI is very flexible for that. It also allows you to handle different content types for your messages, but in that case, you'll probably end up with JSON encoded messages. How can Microcks help in that? Well, let's focus on a simple point for the moment. Microcks will be very helpful, allowing you to speed up the work of the front-end team while the back-end team is developing the notification system, for example. So we are going to see how Microcks can bootstrap your AsyncAPI. It's demo time, and hope the demo god will be with me today. So let's switch to the Microcks. So this is the UI, the dashboard of Microcks, presenting you the different API that are in your system. And Microcks is very contract first driven. We promote contract first approach, but we recently developed this new feature to allow you to having a rapid feedback loop on a new API. This is called Direct API. Direct API allows you to choose an API type. Here we are going to choose an event-driven API, and we are going to publish our notification API. This will be our first release, 0.1, and we are going to handle notification simply. And with Microcks, as it is example driven, you can just specify one example that is the reference payload that will be used to produce simulation and to produce your AsyncAPI. I can use specific notations in Microcks. Here, for example, I want to generate a universal unique identifier for each event, for each message. And here I want some randomness, generating a first name to greet the newcomer in the chat. So I'm gonna hit the next button. And if everything is okay, yes, I got this new notification API that's just right here. So Microcks has bootstrapped an AsyncAPI specification for me. Okay, this is your AsyncAPI file, and you can have access to the documentation. It has generated a subscribe operation with different bindings, and you can see that by default we have a WebSocket binding just right here. So copying the WebSocket endpoint right here and just testing it, I have developed a basic chat front end, and I can connect to my Microcks service and hopefully start to receive messages. Not yet. Let's refresh things. Hopefully it doesn't work. Oh yes, it works. So you can see with Microcks I can really quickly bootstrap my EDA project, really bootstrap my AsyncAPI project, whether for WebSockets or other bindings. Here, for example, the Kafka bindings I will talk about in a few minutes. So this I have some endpoints that are generated for me so that UX team can start working on. And I have also a basic contract that has been generated for me, and I can start to enrich it to complete my use case. So let's get back to the presentation and move on to the second recipe. How EDA and AsyncAPI can help on resource usage optimization. This is a very hot topic today, as most traditional companies are moving to the cloud and they are trying hard to lower the cost due to the current context. And this is where EDA can be used at an application level as new programming patterns emerge. So we are talking a lot these days about reactive programming that is using techniques like non-blocking I/O when talking to databases and dependencies, but Reactive also introduces a lot of asynchronous ruptures to avoid having threads waiting for processors in the chain of invocation. So in this type of design, each processor you can see in the chain will benefit from clearly defining its interface through an AsyncAPI publish operation. Of course, you will have to proceed in reverse order. Last processor publish its interface and so on, reverting the chain. And in the case you were implementing the request response paradigm this way, this is something we used to call stage event driven architecture when using queuing technology in the past. AsyncAPI also allows you to clearly define a correlation identifier that may be used to match the outgoing response from a subscribe operation this time. For this type of situation, you may want to choose some kind of traditional broker like RabbitMQ or IMQP, as those patterns may require durability, but not the long-term persistence of messages. So also on the side of message content type, AsyncAPI has also first-class support for Avro messages that are binary encoded. So this is very interesting for performance here because messages are internal to an application and not necessarily read by humans. So you can have a bet on Avro for performance, but JSON is still an option though. Regarding Microcks usage in that case, you can easily use it for testing different processors in isolation to each other. Therefore, it becomes straightforward to define a set of example message corresponding to expected input and output. And using Microcks testing features, you can really spot buggy processes in your chain. So let's see that in action with our use cases. So as a developer of a processor, I can easily get incoming messages without having to wait for the previous processor to be ready. So if I go back to my notification API I've used previously, I can, for example, see that there is also a Kafka binding that has been provided, and I can easily start to browse the Kafka topic that was created and managed by Microcks. So as an example here, I can just, here using the KCAT, the KCAT tool to see that I start receiving messages and I can start developing my processor. So very, very easy. Now, let's imagine I have developed my processor. And it should respect this user signed up API, okay? And I can test this processor very easily. So let's imagine I start this processor. It is a producer and it produces messages on my topic, on a local topic called user signed ups. You can see here an outgoing messages. And using Microcks, I can easily test it out. So for example, I can launch a new test specifying a Kafka endpoint. Here, the endpoint that is used by my application. I can say that I want to check this operation, and I'm using an AsyncAPI schema runner. And what Microcks is going to do is to connect to one or different brokers in your ecosystem, in your environments, and it will start to collect the different messages that are sent on this broker. And for each and every message it will receive, it will check if the message is conformant to the schema. And here you can see that my processor is correct because the messages that he is sending to the broker are conformant to the schema. So it's very easy to spot the buggy processor, to check here that everything that you produce are conformant to your API and interfaces you define. So really easy to test in isolation. So now let's go to the third recipe that is about how EDA and AsyncAPI can help legacy and technology integration. We all have legacy parts in our information system, and even if AsyncAPI is quite new, I saw very interesting usages of it in legacy context. Technology integration is quite related to this, as it's basically the same concern of integration and managing unreliable network that pushed us to be asynchronous. So the first use case is about legacy integration. You remember those old MQ series, WebSphere MQ brokers that allow access to your mainframe? This is what I'm talking about, and I see a lot of people retro-engineering those chains to take advantage of formal description and tooling acceleration that they may have with AsyncAPI. Heterogeneous, unreliable, and long-distance networks are also now a very common case in industry, smart cities, or edge use cases. So this can really benefit from AsyncAPI being there for describing the common part of the interaction, the commands that are sent by the hub to the different device. So this can be done through subscribe operations, and it can be used to describe the data gathering part through publish operation for describing the data that should be sent by the different devices, for example. And here again, multi-protocol support in AsyncAPI is really a big thing, as we are able to support things such as IBM MQ, AMQP, or MQTT protocol bindings. On the message content type side of things, XML is still a big thing regarding those legacy systems, and AsyncAPI can handle XML message as well. And of course, JSON rises in many edge cases where the interoperability between different devices or different device vendors is the key. One thing that I really wanted to highlight today is the usage I see of Microcks simulation capabilities on the field. Having issues with the cost and availability of mainframe partitions for testing, having concern about the availability of remote devices, all this can be easily simulated using AsyncAPI example support in Microcks. We see many people building complete partner sandboxes using simple but significant mocks with Microcks. For example, in the banking world, a lot of banks are providing open banking sandboxes to allow their partners and their users to play with their APIs. And instead of connecting those sandboxes to existing services on mainframe, some of them have replaced these expensive sandbox environments by just mocks that are served by Microcks. So really a cost-costing solution. Okay, just switch to demo, but go to the recipe number 4. Recipe number 4 is how EDA and AsyncAPI can help modernizing a monolith into different microservices, hence managing the complexity that arises. Let's say you have the need to externalize some modules of your application for a better scale or for an easier way to apply changes or refactoring. And extracting microservices using EDA can be very, very handy. One nice thing about event-driven is that it allows you to decouple the place where events are consumed from the place where they are produced. So if you have introduced events between services and modules, you can transparently extract the modules and still have them consume events. And it's then very easy to retire existing modules in a very progressive way. As a side effect, please note that events may also be useful in microservices world to break the dependencies to improve the uptime and the resilience of an application. Drawback of this being that you may change the way you handle transactions, switching to more loosely coupled methods like, for example, the Saga orchestrations. This may be judged as overkill, but it's really help anticipating the scale up of your application, the scale up of your traffic as you refactor into microservices. So really nice thing of AsyncAPI is that it will allow you to precisely describe your orchestration and your composition process you may implement using Saga. JSON formats or Avro schema embedded into your AsyncAPI spec may be totally appropriated for that. And you can see you can use bindings like RabbitMQ or NATS if you're very cloud native. You probably don't need long persistence of messages in that case too. On the Microcks side, we can specify that we tend to see more and more the need to use local development laptop situation that allows a developer that can't or doesn't want to be connected to complex systems. For example, in case of mobility or offline situation. And for that, we have also developed a Docker extension for that. So just to give you a brief overview, you can install Microcks in a centralized way so that the same instance can be used by different developers, or you can easily use the Docker desktop tool and browse the different extensions in the marketplace and install the Microcks extension. That way you have a ready to launch Microcks and it's just as easy as hitting the launch button. And just after that, you've got your locally running instance ready to be filled with any mock you need for your local development experience. So very handy to have this new way of deploying and using Microcks. Recipe number 5 is all about pursuing this modularization, but scaling it to the organization level by adopting some kind of domain or product-driven orientation. The usage of EDA and events tend to be generalized as the de facto pattern for East-West communications once you cross the boundary of a domain. Okay, I'm really talking about cross-domain boundaries. And this usually goes hand-to-hand with the adoption of choreography as the way to assemble multi-domains processes in the organization. And here again, there is a lot of interesting things in the pattern called Saga choreography. So I really encourage you to have a look at this. Also, to notice a great approach that we foresee in organization is the definition of all the capabilities of a domain through managed API. Could it be for classic REST API for the command, or GraphQL API for the queries, or AsyncAPI for all the things relating to access of unit or data in unit chunks or in streaming mode. Most of the time we see that the data related capabilities are provided by common infrastructure, common services, common team that handles ingestion, cleaning, anonymization, and so on. And I really think it's also a great fit for AsyncAPI, as such service provider can easily describe publish operations contracts that can be simply reused by all the domains that want to consume these centralized services. On the protocol side of things, AsyncAPI can support Kafka bindings, as we already see. It fits particularly well with the ingestion and streaming use cases, but please note that for this use case, the deployment of a schema registry with either JSON or Avro looks like a mandatory step, as schemas must be available and governed across the organization. We specifically added the schema registry support for Kafka in the latest AsyncAPI release, that is the 2.5 release of the spec. So you should really have a look at it. How can Microcks can help you with that? It can help a lot because of its multi-protocol support. We mentioned Kafka in that case, but Websocket is also of interest if you need to expose some data to the outside of the organization, because please don't provide external access to your Kafka broker. Use WebSocket instead, for example. And as Microcks supports both, it's really easy. It really eases the pain testing the different exposition. But Microcks can also help with the schema registry integration, as it is able to connect to the central registry for automation of the publication of the schema updates. And it can also connect to distributed registry to test that the records read from different brokers can be correctly deserialized using a corresponding schema. Let's see that in action here. So, for example, I got a schema registry that is connected to my current Microcks instance, and this registry is empty at the moment. And on the Microcks side, I have preloaded an AsyncAPI that is handling Avro messages. Okay, so you can see there is an AsyncAPI spec, and there is an Avro schema that is attached to this spec. Here is the schema. So Microcks can publish mocks message. For now they are disabled, and you will see there that as soon as I enable the publication of mock message, it will also handle the synchronization of the schema registry with the corresponding schema. So let's check with the property addition, I can now enable the mocking, just save here. So it should start mocking, sending new messages, and as soon as it has started mocking, if everything okay, yes, it has a synced registry with new schema that is attached to the AsyncAPI specification. So it's very handy to ensure the propagation of your schema on the registry. And as Microcks can be also connected to your Git repository, as soon as you have updated your AsyncAPI file into your source of truth Git repository, you can be sure that it will be propagated to your schema registry as well. And here we are finally on recipe number 6, and as a cherry on the cake, I wanted to finish with this one, talking about how EDA can be used in large scale to provide some help in a move to cloud transformation. Because in move to cloud, there's usually this problem of data gravity. You want to start with the easy part, moving one application to the cloud, but the data is still on premises, used and produced by so many other apps. So, as said before, one nice thing about events is that they are easy to replicate, and you can decouple where the data is produced from where it is consumed. Yes, we already saw that, and in that case, let's imagine I have my on-premises and my cloud environment, and the first things that we have to do is to set up a replication of events to the cloud or to the clouds of my choice. For that, I probably select a globally available broker like the one from Soleil, from Google PubSub, from AWS, or even Kafka with mirroring, for example, if you're managing different regions. And the nice thing is that we support all of them in AsyncAPI. So once the replication is done, you can start deploying new consumer C on your cloud provider. This is transparent, totally transparent. Then you can move adapted consumer B on the cloud before retiring it from the on-premise. And when finally you are ready or you want to move the service that is on the top, you just have to move it and to revert the replication. Okay, now the master is the cloud environment and events are replicated to the on-premise environments. Finally, you can retire your on-premise services, and maybe the consumer A that sticks on premise or that will stick on premise forever continue to receive environments in a very transparent way. As with the previous recipe, Havro and JSON with schema registry are perfect candidates for that. But note that it may also be of interest to consider something like cloud events that can ease the registration or the interoperability of your own events with the one of your cloud platforms you chose. And luckily, AsyncAPI is also compatible with cloud events, as I described it extensively in a previous talk last year. So you may have a quick search on YouTube, search for my name and cloud events or AsyncAPI, and you will probably find this detailed video showing how they can be combined to provide great power and great interoperability. Finally, where to use Microcks in this picture? And I would say everywhere, of course, because it also supports the different bindings and supports cloud-based broker. So it could be of great help for anticipating and preparing migrations, as well as ensuring there is no regression once you've started moving components or revert replications, for example. So basically, you can see Microcks everywhere. So time is flying, and it's the time to wrap up things. So as you say, it's a journey, and if I succeed in my demonstrations, you now understand that EDA plus AsyncAPI plus Microcks can be a very helpful combo in a lot of situations, from purely tactical to more strategic approaches. As said in the introduction, I chose today to have a very progressive approach, but this is not necessarily a path. This was easier to have this progressive approach to introduce concept one by one. But you can really start from the right and then also consider recipes on the left. Start having a global approach and then a local optimization approach, or going the other way. It's really up to you to, let's say, to build your own menu, depending on your scope of action, depending on the maturity of your organization, and a lot of other criteria that matters for you. Just final words of Microcks. We are open. We welcome everyone to come to share ideas and to contribute. The project is purely community and user driven. So this last month we implemented a lot of stuff regarding users' requests, regarding the supports of new brokers, the supports of new approaches, of testing approaches. So it's really up to you to come and join the community. Try it and give us feedback. And this is the final words. Many thanks for attending this session. I hope it has been worth your time, and I hope to see many questions in the chat. Bye bye.